Very good morning, students. Today we can continue the topic, that is system of particle and rotational motion of physics. Okay. So the last point which we have learned is the moment of inertia of a different bodies that we have calculated. Okay. Moment of inertia of ring, disc, solid sphere, hollow sphere. Okay. Cylinder and so on. All these parameters, all this moment of inertia, the radius of gyrations that we have been calculated. Today we can proceed for the kinetic energy of rolling body. Okay, sir, what is exactly kinetic energy of rolling body? So what is the rolling body? Which type of motion the rolling body possesses? So the first point, the rolling body has two types of motion. It is the combination of two types of motion. That first is the linear motion, that is also called as translational motion, and the second is a rotational motion. Then question arises, sir, what is exactly linear motion or translatory motion of a body? Okay, what our aim is to find out kinetic energy of rolling body. For that, first of all, I am going to explain to you what is linear motion, then what is rotational motion. Linear motion, you have learned, it is defined as the motion of the body which moves along the straight line with respect to some reference point. Okay, so that means when the body is moving along the same straight line, then at that time this is called as the linear motion, or this is also called as translatory motion or translation motion. And the energy in that case the body possesses is the kinetic energy, linear kinetic energy, which the energy possessed by that body, that is the linear motion. The second motion, that is the rotational motion, which the motion is there, rotational motion. So what is that exactly, rotational motion? Okay, so rotational motion means the motion, it is defined as the motion in which the body moves. That means in the body all the particle moves that means along the circumference of circle in a such a way that their centers are lies on the axis of rotation. So that is called as the rotational motion. Again, I will define what is rotational motion. Rotational motion means this type of motion in which when the body moves, then all the particles are moving along the circles and the centers of their circles, okay, because different particles have the different circles, but the centers, they are lies on the axis of rotation or one imaginary line. That line we have labeled it as a axis of rotation. So then that type of motion is called as the rotational motion. And the energy, kinetic energy which possessed by that body is called as rotational kinetic energy. Okay, so that things you have clear. Now once you got the idea about the two types of motion, linear and rotational motion, then we are coming to the point, sir, what is a rolling motion of the body? Rolling motion. So naturally now rolling motion is the combination of linear motion and plus rotational motion of a body. If you add both this motion and when the body starts moving, then that is called as rolling motion. You see here, suppose this is the body. If body moves directly like this, this is the translation motion. If body rotates about its axis of rotation at the same point, then at that time this is rotational motion. But the body possesses the rolling motion when the translation and rotational both they combine together. Means here in that case this body is moving forward direction also along the same straight line as well as rotating about its own axis also. So that motion is called as the rolling motion of the body. Okay, and we want to find out kinetic energy of rolling body. So naturally kinetic energy of rolling body can be calculated by using the formula kinetic energy of linear motion plus kinetic energy of rotational motion. If I will add both these energies, then at that time that energy which we will get is the kinetic energy of rolling motion. So now what is the linear kinetic energy of linear motion? 1/2 mv square, where m is the mass of the body, v is the velocity of the body, and rotational motion is 1/2 I omega square. Okay. So now here in that case, if I will write down mv square plus 1 half, I will be written as mk square, and omega is equal to v by r. So v square by r square, and if I will take 1 half mv square common, then in bracket it will be remains 1 plus k square by r square. So that is also called as kinetic energy of rolling body. So this is the first formula what we got it here. M is the mass of the body, v is the velocity of the body, k is the radius of gyration, and r is the radius of the body. So that is the first formula. Second formula I can also write down like this: 1 half mv square r square plus k square, r square plus k square divided by r square. If I will take r square out, so then 1 half mv square by r square plus k square. And you know v square by r square is nothing but omega square, because v is equal to r omega, omega is equal to v by r, so therefore v square by r square is equal to omega square. So that is equal to r square plus k square. This is the second formula for calculating the kinetic energy of rolling body. Okay, so you got the formula for kinetic energy of rolling body. Either you can use this formula, 1 half mv square 1 plus k square by r square, or 1 half m omega square r square plus k square. Here in that case, only when v is out, then 1 plus k square by r square, and when omega is out, omega square, then r square plus k square. You remember these two formulas, both the formulas which can use for the rolling motion depending upon what the parameters he has given v or he has given the omega to you. You are able to do that things. Okay. Once you got that the idea about the linear kinetic energy and rotational kinetic energy, and then this is way how you are calculating the kinetic energy of rolling body. Now once you got that idea, then we want to find out the linear velocity of rolling body. Okay, if I want to find out the linear velocity of rolling body at the different points, then what you should remember? Okay, first of all, you should remember the velocity of linear motion of that body plus the velocity of rotational motion of the body. And if you are combining both these velocities, you are getting the velocity of that rolling body. So sir, calculate the velocity of rolling body now. Okay, so once you got the idea about kinetic energy of rolling body, then we are coming to the point, what is the velocity q1, linear velocity, or we can also say that linear velocity of different points, linear velocity of different points of rolling body. Okay, if I want to find out the linear velocity of different points in a rolling body, okay, linear velocity of different points in a rolling body. Okay, so now you see here, so the body have the first of all the two types of velocity. First velocity is the linear velocity to that body, but linear velocity means this which motion, translatory motion, plus the body have the which velocity, angular velocity. Okay, angular velocity means velocity for rotational motion, velocity of rotational motion, linear velocity of linear motion, linear velocity of linear motion. Okay, here, and if I will combine together, then I will get the linear velocity of rolling motion. Okay, so now you see here, this is the picture which I am going to create here. So if suppose I will consider the two cases. So linear motion velocity is the linear velocity. Yeah? So this is the velocity of center of mass. Okay, so this is the same velocity of center of mass. In all the direction, velocity will be velocity of center of mass. Whether you are taking the point A, B, C, D. Okay, so these are the 4 points which I am considering. Here also, in rotational motion, velocity is equal to r omega. Okay, So here in that case r omega means that v will be in this direction. Here v r omega, okay, in this direction. Here that will be r omega in this direction. Here r omega in this direction. Okay, so that is the velocity of rotational motion. So that is also called as velocity, velocity, velocity. Okay, so here also velocity of rotational motion v is equal to 0 here at the center point. You just check the timing, more than 15 minutes it should not proceed. Okay, so how much time is left now? So I think so. So can I continue? Okay, so there is no problem. So the velocity of rotational motion can also be calculated by addition of both this motion. Okay, so at this point A, B, C and D point. So these are the 4 points are there. Okay, so now in that 4 points, first of all, if I'll take the point A, B, C, D, you see here, r omega plus r omega means 2 times velocity of center of mass. Okay, here at that time only velocity of center of mass. Here at this point velocity of, that means your center of mass is this direction, here that r omega is this direction, so therefore here this angle is 90, so therefore resultant will be here root 2 VCM upon VCM means V square plus V square 2 times V square. Okay, and 2 times root V square is equal to root 2 times V, that is your center of mass. Okay, this is the 1 point. So now here at this point velocity will be, one is moving in forward direction, one is moving in backward direction, so velocity will become 0. Okay, so that will be the velocity of center of mass. If I will take the different points A, B, C, D, here this is the E point, here this is the F point. E point is located at a distance of r by 2. Okay, so this distance is r by 2. F point is located at a distance of, suppose r by 4. This point is at the distance of r by 4. Okay, so now the same thing here, E point, here this is the F point. E point which is lies in the middle and F point is in the middle part. Okay, so now you see here, in that case if I want to calculate the velocity of center of mass, here the velocity of center of mass will be remain same. Here that velocity will be r omega by 2. Okay, and here at this point what will be the velocity at point E? At point E will be V.
13 minutes.
13 minutes are done. Okay, now only last minute. Okay, I'll just take 2 minutes more. VCM plus now I will take here r omega by 2. So that is VCM by 2. That means 2 plus 1, 3 by 2 VCM. Okay, at point F, suppose at point F. Okay, at point F, suppose this is the another point. You see here, F point is lies here, means that velocity will be VCM here at the same velocity. Here r omega by 4. Okay, it will be same here, r omega by 4, and so therefore VCM plus r omega by 4, but that will be negative side. Okay, so therefore if this is VCM 4 minus 1, 3 VCM by 4. So this is the, at different points you can calculate velocity. So if you can make a triangle, then you can get that VCM will be at this particular point. Suppose this is the point A, that is VCM will be maximum 2 times VCM. Okay, here at this particular point E, that your answer will be 1.5, 3 by 2 VCM. Okay, at point B it should be VCM. Okay, at point F it will be 3 by 4 VCM, and at point C it will be 0. So this is way that velocity will be there. Okay, so these are the velocities at different points. We'll stop here at this point.